All right, here are solutions for quiz 3 for Math 1 to 12. The first problem, we're just, I don't know, dealing with logs, I guess. Each of these are either equal to some number or does not exist, and you're supposed to say what number it is. So on the first one here, the log base 4 of 16, well, it turns out that that's equal to 2. The reason that's true, although you don't need to tell me that, is because 4 to the second power is what equals 16. What this question is asking you is to what power must you raise the base 4 here to make it equal to 16? And since 4 to the second power equals 16, the answer is 2. By that same logic, what power do you have to raise 4 to make it a 2? Well, you'd have to take the square root of it, which is the same as raising it to the 1/2 power. 4 to the 1/2 is the same as the square root of 4, which is 2. The log base 2 of 1/4. One's a little bit tricky. What power do you have to raise 2 to make it equal to 1/4? Well, the answer is -2. And the logic is that 2 to the -2 power is the same as 1 over 2 squared. And 2 squared is 4. So 2 to the -2 is the same as 1/4. The natural log of 1, turns out that's equal to 0. The reason here is because the natural log is asking you what's the log base e of 1. And e to the 0 power is equal to 1. Log base 2 of 0, that's undefined. I don't know, can only take log of positive numbers. 0 is not a positive number. The natural log of e, turns out that's 1. And the reason why is because e to the first power is what's equal to e. And the natural log is the same as asking you the log base e. This one, I don't know. I guess I thought I was being funny. I don't know what I was doing here. The natural log of e raised up to some power. This is asking you the question, to what power must you raise e to make it equal to e raised up to the -2.71828 power? Well, that answer would be -2.71828. And I guess the logic would be because e to the -2.71828 is equal to e to the -2.71828. The log base 5 of the negative of 1/25. Turns out that's undefined as well. And the logic, again, you can only take logs. I guess I said log above, of positive numbers. So that's what I was going for here. You didn't have to give me the explanation. I might even say all this explanation here is optional. If you got those answers, I'm happy. All right, number 2. I actually am going to change the problem a little bit. I'm going to have you consider the graph of log base 2 of x plus 4 minus 1. I'm asking you the question, what is the y-intercept? Well, the way to figure out, I'm asking you the x-intercept first. So the way to figure out the x-intercept is it happens when the y-coordinate equals 0. So really, to figure out the x-intercept, all I have to do is solve this equation right here. Solving equations with logs in them is a little bit challenging, but I think we'll be able to deal with it if you first add 1 to both sides of the equation. You get here. And now this is written in logarithmic form, but I would prefer it be written in exponential form. I can write it in exponential form. I can say 2 to the first power is equal to x plus 4. So 2 equals x plus 4. And therefore, if I subtract 4 from both sides, I get x is equal to -2. And when I'm trying to figure out the y-intercept, the logic is pretty similar, except now instead of the y-coordinate being set equal to 0, it's the x-coordinate that's set equal to 0. So I could say something like, I don't know, y equals the log base 2 of 0 plus 4 minus 1. Well, that's the log base 2 of 4 minus 1. And the log base 2 of 4 is just 2, because this is asking you the question, to what power must I raise 2 to make it a 4? Well, that answer is 2, because 2 squared is 4. So I get 2 minus 1. I got 1. Does the graph have any asymptotes? Yes, it sure does. Because it's a logarithmic graph, it has a vertical asymptote. It has a vertical asymptote. Okay, but where? Well, our standard logarithmic graph has a vertical asymptote at x equals 0. But this isn't our standard graph. This minus 1 shifts everything down by 1. Well, that's not going to affect my vertical asymptote. But this right here shifts everything to the left by 4. So that vertical asymptote that used to be at x equals 0 is now at x equals -4. Wow, that's a long quiz. Now there's another question. Part 3 here says express this mess as a single log. Well, to do that, you want to use your log rules. And to use your log rules, well, maybe the most obvious, the rule that you might be staring at is this negative right here. I'm subtracting logs. When you're subtracting logs, you can change it into the log of a quotient, something divided by something else. True, except you got this 2 and this 1/2 here. So deal with those first. This is the natural log of x plus 1 squared minus the natural log of 3x to the 1/2 power. So something like that. And now you can make it all one big log. Natural log of x plus 1 squared divided by the square root of 3x. You don't have to write it exactly like this, but this would be one possible correct answer. And I guess that ends the quiz.